let's go ahead and get started. Well, hello and welcome to another installment of the Good Design is Good Business series. My name is Roger Snook. I'm your host today. I'm part of the IBM Rational team, in particular on the worldwide enablement team, supporting the offering, strategy, and delivery of the Rational products, which is basically between the sales force and the product development teams. And part of our mission is to educate our teams on our capabilities and offerings and standards, especially when it pertains to several different areas such as mobile or, as we have today, things in the good design space. And the architecture, design, and construction community, if you're an IBMer, you probably are a member of that. So today, I am pleased to welcome Irv Bader, who is our guest speaker for today. And our topic is on SOA and telecommunications, and in particular, the TelcoML, which is a standard being forged in the industry. And I'll let Irv tell you a little bit more about that. But just a few notes and etiquette about today. Today's session is being recorded, so if you are not in favor of that, go ahead and disconnect now. We will open up the lines. All lines are muted now, but we will open up the lines very soon for questions for Irv, and then we'll close down the lines again and open them up at the end, and there'll be additional instructions for that soon. This event, as well as other events, again, are listed on the Good Design is Good Business Developer Works site. So please visit there. We have updates on RSA and RAD coming up for the 8.5 versions next week. But without further ado, let me go ahead and introduce Irv, who is our worldwide go-to-market manager for energy, utilities, and communications industries at IBM Rational. Irv is the co-chair of MARTE, TelcoML, and the OMG's Smart Energy Standards. So I'm really excited to have Irv today on the call. Irv's written over 50 papers on real-time and embedded systems and model-driven development, and is nearly years of experience in developing software and marketing complex. Something you may not know about Irv and I both are and technology guy, but also a good citizen in his local community as well. So with that, Irv, I am pleased to hand over the baton to you, and thank you for today's session.
Thank you, Roger, and especially for taking time from your vacation to hold this little symposium today. I just wanted to let you know that you got it chopped off a little bit because you're on a mobile connection. I think what Roger was trying to say is that we are both very involved in the junior soccer, ASO, American Youth Soccer Organization, and me as a referee and he as a coach. So I would definitely admire that part of your background. So just starting off, Irv Bader from Rational, and I'm noticing most of the attendees are from IBM today. I'm very excited this is the first time we're publicizing internally to IBM this very nice standard. Most of you probably are involved with SOA, or at least have heard about it. And what we're trying to do today is just to expand on it and see how it is relevant to telecom industry and where it's coming from, where it's going. So today's presentation, I'm just going to start by talking about the little history of it, but then what was the motivation and how it came about, why is it needed even, and then very little bit on the marketing, on how are we going to market that as IBM, how to sell it to the customers at IBM. And Roger, please stop me if you don't agree with any of these agenda, especially the marketing side, but I'm not going to spend a lot of time, but it's very important when a new standard comes to make sure that it is getting adopted very well. And since some of you may be involved with the customers directly or indirectly, I included that item in today's agenda. And finally, we're going to go into the technical details of TelcoML and how it came about and where is going to be technical future for this standard. So for those of you who are familiar with SOA and its evolution, you probably know that SoaML was one of the first major attempts at customizing SOA. It started off with an initiative called UPMS, UML Profile for Modeling Services. My very esteemed colleague from Rational, Jim Amsden, was the initiator, and to the last day of SoaML, before it became a standard, he was chairing that. So SoaML is a very IBM inclined standard, and I think it's overdue to get its fair share, in especially the telecom, but in general business and IT community. So we started using SoaML in its present form called TelcoML because we wanted to make it domain specific. We started in 2008, and one of my biggest partners, and to this day the biggest partner, is France Telecom, our research and development team up in Brittany area of France. Very nice area, by the way. And the whole team is very dedicated to especially rational tools. We have quite a lot of adoption of RSA and old telelogic tools there. So telelogic, as you know, has a fairly long and deep roots in modeling. So France Telecom's campus in Brittany is a big user of telelogic tools and rational RSM, RSA type tools. A lot of the work that we did together to realize this standard was done using RSA in this case, and most of my diagrams I'm going to show you uses RSA. So architecture board at OMG, which is presiding over the new standards, approved this in December of 2011 to become a global standard. We initially presented in March, so it took us close to 8-9 months of iterative workflow with the architecture board to get this approved. And the reason was a lot of the architecture board members are seasoned modelers. They were very critical of some of the stuff, but another more before we made this into a standard in December 2011. So what we're doing now with this is that we are refining the standard more and more to include a lot more other telco paradigms. And I'm going to talk quite a bit about one of them, TM Forum's SES, which stands for Software Enabled Services. It's a group at TM Forum. I'm sure that most of you know what TM Forum is. They're the big standardization group, circa NGOS and frameworks of the current fame. So Software Enabled Services group have a standard called SMI, which stands for Service Management Interface. And our latest exciting development is that all of the TM Forum's SES mandates are now going to be TelcoML compliant. So we will see some of the representative profiling that they've done later on in this presentation. And one of the things we're going to continue doing is using OnAPI, which is a very common API used in mobile devices currently, which is a standard from GSMA. The organization who maintains the 3 and 4G type messaging standards, that we are using that as a proof of concept in this standard. So we're going to continue aligning with OnAPI as it evolves. And in next year, sometime in mid-next year, we will do a version 2 of this library. As you can tell, this is a living standard, meaning it's not a very theoretical standard. It's a very applied standard. So what we're going to keep doing is growing it for new applications. Maybe the core standard will stay the same, but the applications will continue to increase. So now the main motivation behind was twofold. First, obviously, was we're a modeling group within IBM, and we want to proliferate modeling tools. SOAML, which is, again, an IBM-led standard, was also aiming to do this, and it did a great job of bringing SOA to the mere mortals, the UML users, that is. And if you notice, the SOA specification itself is extremely broad, and it does not assume any kind of a modeling inclination at all. So SOAML was able to translate SOA into UML, and as I said earlier, it's not getting its fair share of adoption because it's actually quite a voluminous and quite an easy to adopt UML version of SOA. We have tons of SOA customers, but not for you. So obviously that was a big motivation for us, is to finish the SoaML dream, at least in the telco domain, and then go from there. The other one was that the other motivation was there's a lot of APIs going on in the telco industry, especially in the wireless side. So the wireless app development is mushrooming right now. Every day there's a cutting-edge application coming out. And if you notice all the standards they're using, they're fairly sparse in terms of standard usage. Everybody's doing ad hoc type of API development. And that's not a good thing, because we all know what the risks of doing that way, the technology that way, is you cannot do interoperability, you cannot share components within an organization or across different organizations. And unifying some of these APIs as model components allows us to do all those things, configure management, our components, share them across different organizations, standardize them so all the applications are interoperable, and they can talk to each other and so forth. So these two motivations made us refine SoaML, and then tell the industry that just expressing SOA and UML is not enough. We need to actually translate that into a more domain-specific version, and TelcoML was realized. And when we presented this to the OMG board, they were totally in favor of this. And because OMG as an organization is realizing that UML has been out for such a long time, and UML2, which is to me is a fairly different language than UML1 was, but UML2 itself has a fairly smaller adoption than we thought 15 years ago or so when it came out. And the reason is because they're realizing it's not domain specific enough. And SOA was not an exception. So anything that you're expressing in SoaML needs to be still refined into a more domain specific version, and board totally realized that, and we were given a green light to go ahead with the standard. And then don't forget that OMG is also the keeper of these pre-SOA standards like CORBA, which is how it actually got started. And CORBA was done very specifically for telco domain. So OMG had this hindsight and foresight to bless the standard. So what we ended up doing then is to define TelcoML in two different branches or two different forms. One is the enabler library, which basically is the UML-based diagram expressing telco in SoaML. But what we also did was we did the composite service side of modeling as well. By that I mean the behavioral and executable modeling technology. Now SoaML specification alludes to both these branches. It doesn't talk much about this composition, doesn't talk much about behavior, in other words, executable model. But in telco, especially on the device side, executable modeling is a very common practice. So companies who, my associates in this project, France Telecom, Orange, and AT&T, they're all using executable UML at the device level. So it was a very automatic choice for us to take not just the structure of SoaML, but also the executable and behavioral part of SoaML, and produce that a little bit farther into a full-fledged language. So with that, I'm going to introduce some background material for SoaML. Where is it coming from, and where does TelcoML fit into this, basically? So servicing is the job of SoaML. What it does is it creates an environment where a consumer can ask for a provider, and the provider will be able to announce a service, and the consumer will go and using a known protocol and a known interface and consume that service. That's basically, in a nutshell, how SoaML works. So any protocol that specifies how the capabilities are present can be turned into a SoaML interface, but it doesn't really focus on the implementation too much. So we know the how of the capability, but not how of the implementation of that service. And that is by design, because we do not want to bind a customer by a technology or by a methodology, but we want to bind them by an interface. And that's basically what the crux of the standard is, SoaML is, that is. There's also things like constraints on services that SoaML imposes. You can define a constraint on a service. You can also do some sort of a quality measures. You can impose quality measures on your services, such as cost, the availability of the service, the performance of the service, how big the service is, its footprint, and also whether or not it's suitable for a certain task or not. You can define all that in SoaML. We can also impose policies on a service, such as security policy, scope of a transaction, and maintaining security and integrity for the overall system. So those things could be defined as SoaML interface. So it's, as you can guess, it's a pretty versatile and a fairly wide-ranging standard. So how does it look? I'll give you an example diagram of SoaML. It looks very close to a UML diagram that all of us are accustomed to. So if you notice, it may be a little hazy, but I'll explain the diagram. But what SoaML does is it comes in a few different interpretive flavors. The one that I'm showing you right now is a service interface interpretation of SoaML. SoaML also has what we call a contract-based interface, where instead of using a service interface stereotype, it uses a service contract interface. And you probably have guessed that what that means is that the contract or the nature of the service itself is standardized, but the interfacing behind that is left elastic. So the contracts, when they come up, they can define their own service interface either on the fly or application-specific to that contract. So it's a contract-oriented version of SoaML. What we used in TelcoML is the service interface part of SoaML. And what that means is that you define an interface to the service, and that interface could be a collection of other interfaces, and it could be composed of different interactions. So which is what I'm giving an example of. It's a BSS example from Telco. It's the billing system of a small organization there. And if you notice that it consists, the invoicing service itself consists of two different interfaces, which is invoicing interface and an invoice processing interface. And then obviously there's a whole set of requirements known as invoicing that it's relating to. So if you notice the composition of this invoicing service, which is one of the SoaML services, it basically consists of two types of interactions within itself. One is the orderer and one is the invoicer, so the person who orders stuff and person who invoices that ordering entity. They are the composition of this service. So just getting a little bit technical, but I wanted to illustrate what we mean when we say SoaML is basically a service interface oriented standard where it takes the service and then creates a fairly descriptive interface, not just in terms of the protocol, but also in terms of the messaging part of the protocol. So in this case, the messaging entities are the ordering entity and the invoicing entity. So the next example I wanted to show you was how do we illustrate things in service interface. So if you notice that we can model data as a separate entity, but within the scope of the service interface that I just mentioned. So in this case, the invoicing is, for example, a service interface, but behind it, it uses some of the data that's involved in invoicing, and that data could be modeled in the regular UML format. In this case, you notice there's a purchase order data that's a class that interacts with the invoicing class, manifestation class, and scheduling class, and so forth, to allow the service called invoicing to exist and use the data. So basically, the SoaML is nothing new to UML users, and it uses a very fixed protocol to define its interface and services, but in the background, it uses the same old diagrams and data diagram from UML as an example for that. So pretty soon, we'll be able to open up the first round of questions. So if you guys have any questions, Roger, would you allow these guys to ask me some questions?
Yeah, go ahead and flip to the next chart, and we'll go ahead and open up the lines here.
All participants are now in interactive talk mode.
Actually, the lines are all now open, and as you all think about some questions to ask, I'll just remind you that there is a chat window on the right-hand side of your presentation. So there's some links and other bits of information there that hopefully you'll find useful. But does anyone have any questions for Irv so far?
There are already services standards which are OSSJ and MTM and MTOSI, which have defined services interfaces messages. Is there a plan to capture those in preloaded models, or?
I heard one of our customers talk about it, but currently there's a bigger push to do the SMI, the Service Management Interface from TM Forum that I mentioned. So we're putting that as a profile right now within RSA. In the future, it's very easy to put the services that you are talking about as well. But currently, I think we're focusing on the SMI and OnAPI right now because there's a bigger demand for those. So if you see otherwise, please feel free to tell me, and then we can do a little poll within Rational Telecom groups and see if we should change our strategy and include some other services.
And the other question is, RSA also has a BPMN capability, and you can connect, pools and tasks. You can say create a service capability from this task or this pool or this process, or do the opposite, consume. Is there a plan to connect TelcoML and BPMN, or it's just natural given that already SOAML and BPMN are connected in RSA?
That's exactly the last part of your question. That link to business process modeling is already part of SOAML specification. And what TelcoML will do is, as you probably guessed, what happens is we have a business process which turns into a service interface, which turns into an implementation like WSDL or whatever. So where TelcoML comes in is at the service, at the middle layer, service interface layer. So any business process that's linked to the service is already linked to the TelcoML by default because of the SOAML. So don't forget, when you implement TelcoML in a tool, it's using the meta model or the profile that SOAML is using. So it automatically inherits all these relationships. So TelcoML is automatically linked to BPMN because of that. Yeah, but good question.
Yeah, and we actually did a chat on that led by, I think, Todd Donovan and Gary Johnston. I was just trying to look up the link right now, and I'll put it in the chat window if I find it here. Just a moment. But we did do a chat on that, and recordings and slides are available on that BPMN and SOA integration in RSA. I also wanted to point out, Irv, that also on our call list today is the product manager for RSA, Don Yancey. So welcome, Don, as well, to the call. Any other questions for Irv?
I think Charles Rivet on my chat screen has asked, is the data model using the SID models in RSA extension? Currently, no. The SID, for those of you who are not familiar with it, is the old messaging interface from NGOS days using the TM Forum's old standard. And not right now because, first of all, we are focusing on the SES SMI from TM Forum because that's replacing SID pretty much. And sooner or later, RSA will implement SES SMI, in which case what we'll do is instead of recreating that in our own profile, like we are doing right now, we will just use the RSA's native, either the meta model or the profile for SES SMI.
Because SID is already available from TM Forum as an RSA model.
Yes, I understand. I understand. So what I think ideally what we should do is, since SID has got a fairly good adoption right now, ideally we should have TelcoML both expressed in terms of SID and SMI. That way, we have covered both bases. So it's a good point. I'll definitely bounce that off of the RSA product group. We have been talking to Nick Tashima, by the way, about this, and currently what I'm doing is with the help of my France Telecom colleagues, I am writing this plugin for RSA for TelcoML, which we'll probably put on DeveloperWorks in August to September timeframe. And that way, at that time, we'll see if we can use SID.
And for those who are interested, this is Mark Fermante. I had the ETOM decomposition as an RSA folder structure also, so which is the other.
Can you say that again, please, Mike?
TM Forum provides, the decomposition as a static structure of packages, you can map that to UML packages. And I had that as an RSA project also.
Is that on DeveloperWorks?
It used to be internal, so if you, because we had that part of the WebSphere Telco pack at some stage.
Very good. Well, Charles Rivet, who's our OSD lead, he's asking you to introduce your full name so we know who you are, so we can bother you later on.
I'll put in the chat. Mark Fiamante.
Mark Fiamante. Thank you, Mark.
That's in the chat.
From anybody?
Yeah, Roger, this is Steve Eisreich. Real quick, you mentioned earlier that Sparks is on the OMG standard too, as part of this the TelcoML standard.
Yes, Sparks was one of the chairs of the architectural board.
All right. Well, I know we have quite a bit more material to cover here as well. The lines are pretty quiet otherwise, so I would suggest I'm not going to mute the lines, but I'll rather just leave it in interactive mode for us, and just let the questions fly as they come up, if you're okay with that. And otherwise, I would say go ahead. Please continue.
Sure. So, and everybody, you can just also send me a chat because I have my chat screen open as well. So, anyway, so let's get deeper into TelcoML. We were just talking about the background material, and we were talking about SoaML itself and how TelcoML is such a thin layer on top of SoaML. But because of the definition of the interface and especially the domain specificity of TelcoML, it makes a huge difference to the adopters in the telco industry. So let's talk about what it does by itself on top of what SoaML already does for us. So there's two parts to TelcoML, as I expressed earlier. The enabler library is what we're used to seeing. It's the interface part of it. So what we do with that is define the popular interfacing in telco using the enabler library. I hate to use the word API because it reeks of programming, but API is a very widely understood term. If you notice any domain in the industry right now, especially in the wireless horizontal industry, everybody's using API. There's such a big buzzword. Companies like Bank of America and Chase Bank, they are defining their competitive advantage for customer service based on their superior API over the other. And that kind of a API wars is existing in a lot of different industries right now. So we realize that we shouldn't stay away from that term because it's, all of our customers understand that. And eventually I think this wireless API will get out of telco and go into banking and finance and energy and any kind of customer service-oriented industry. So we're going to preserve this terminology. And then to start with, the biggest adopter of TelcoML is telecom industry. So as a proof of concept or proof of technology, both, we used the OnAPI from GSMA as our enabling standard. And then what we're going to do is, as I said before, do the SMI from TM Forum, and then go from there and adopt a lot more APIs as part of our reference implementation. The more exciting part of TelcoML, which probably is not going to be adopted as widely as the enabler library part is the composition profile. Again, it interprets the service composition part of SoaML, but it does executable modeling, something that we're very proud of at Rational, especially from the Telelogic lineage, where executable modeling through Rhapsody, tools like Rhapsody and Telelogic legacy tools, we have close to like 20 to 30 years of solid executable modeling legacy. So we're able to introduce that into the standard, which is quite exciting. So going forward, let's go into a bit more detail. Starting from the enabler library, the structural part of the standard, it basically is a reformulation of SoaML using Telco API as subjects here. So the typical usage is to model the interfaces using any kind of a modeling tools, in this case RBM, RSA, but also fully executable frameworks like TM Forum's Joseph tool, JOSIF tool. By the way, TM Forum is modeling a lot of TelcoML compatible interfaces right now, SMI being one of them. Joseph to do all that. So in the future, they can put it in an executable framework. What we did was we not only did the structural modeling to the enable library, but we're also leaving it open for executable frameworks like Joseph and also the IBM RSA's executable model standard that is forthcoming through the UML standard, again known as UAL, UML Action Language, and executable model that goes with it. So the main interfaces right now that we have already included in this standard are the messaging part of the OnAPI. So those are the SMS and MMS interface. We did not model more than maybe 75% of the OnAPI because some of those contents of it is extraneous to our illustrative purpose here. But most of our customers, I'm sure, who'll adopt TM TelcoML will put more of API in there, more of the OnAPI in there. So we're focusing very much on the SMS and MMS part of OnAPI, plus the simple messaging interface, the text messaging and so forth that goes with it. There's another standard called click-to-call, which we have implemented along with OnAPI. Then the location services, again, is part of it's an extension to OnAPI that we have included in the specification. Synchronization and voice recognition APIs are also expressed as TelcoML. So it's a fairly nice and practical paradigm right now. So once we see that in RSA model and on DeveloperWorks, probably September, late August, early September circa timeframe, you will be able to use some of those services as part of the plugin that we're doing. And as I said before, the TM Forum team is extremely busy right now expressing SMI as TelcoML. There's about 4 people working on it right now, which is quite encouraging. We have weekly meetings, and we review their progress so we can make their standard as part of our annex to TelcoML. So very exciting things going on. Let's just illustrate some of the OnAPI inclusions that we have in TelcoML. So OnAPI has a SMS generic interface. So if you look at it from a SoaML perspective, you'll realize that you can express the whole SMS as a service interface, which is a collection or composition, I should say, or interaction with 2 different service interfaces. One is the reception part and one is the delivery part of the SMS. So for those of you who know OnAPI already know this, but if you look at the OnAPI, it's HTML style interface, and it's very cryptic. So by just putting that in a SoaML framework, you realize that you can quite easily illustrate and extend that. So in this case, what we're doing is we're defining all the properties related to SMS that's part of the OnAPI, but by looking at the HTML side of SMS from OnAPI, you're not going to be able to tell easily what it's doing. You have to read some text documentation for it to realize what's going on over there. So by putting it in a SoaML format, you're able to domain specify it even further to your organization or extend the SMS, which a lot of the companies have done already. In fact, this SMS is an extension of the vanilla OnAPI SMS that you find in the HTML code. And then the other things that it's using is we don't want to belabor the service interface. That's not the spirit of SoaML. So we left all the data types within the scope of this service interface, but not as part of its properties. So that way the illustration is much more clear of its capabilities, not of its mundane data type details and data type details, which are left out of the scope. So if you want to show those data types, you can show them as ancillary artifacts like is shown in this diagram, and leave it out of your main diagram. So it makes the diagram a lot more appealing and a lot more easier to understand. So another example is location services and generic messaging services from OnAPI. If you look at the HTML, again, it's extremely cryptic and very difficult to tell that the messaging part of the OnAPI has just about 6 to 7 different properties, and that's it. You can send SMS, MMS, the email, the instant message. You can send a voice packet, or just send a generic message as a string using the messaging interface. It's that simple, but not very obvious when you look at that service. Similarly with location services, you can do a single or multiple entity location queries very easily using OnAPI. But by illustrating it in TelcoML, you'll realize that it becomes really easy to understand. So now that we're working with TM Forum, we'll hopefully have a joint standard notation for these, which is our goal, is to have TM Forum refer to TelcoML for SMI. But what they've done for us is give us the basic SMI base class as a TM Forum. So this is actually 4 or 5 months old now. So that by now they have about 8 of the SMI interfaces defined in TelcoML. But the SMI itself being the first original TelcoML interface that we got from TM Forum, you realize that for those of you who are familiar with SES SMI, you can actually query and set the execution of a service using their interface. You can also generate reports. You can also get the service configuration information from a service using their SMI interface. So when you express all those in TelcoML, it becomes very familiar SoaML interface no matter what you're doing. So basically, one of the big things that we realize that TelcoML will do for us is take all these very unrelated messaging standards like SMI and GSMA's OnAPI and make them look very similar to each other, which was our goal. So this is one illustration of that. And again, we left the data types and enumerations outside of the service interface, as SoaML tells us to do, so that they become ancillary but still good information snippets for us if you need to get that. So I would also go a little bit more into the more interesting features of TelcoML, which is the service composition. Service composition is, again, the executable UML part of this service. SoaML defines that as a service composition and does spend a little bit of time explaining it, but does not illustrate it very widely. And if you notice, the audience of SoaML is very much IT and business user-oriented, where executable UML type of paradigms are not that common. However, the TelcoML itself does not ignore the IT side, and I'm going to mention that later on in a minute. But it's also very much systems or embedded systems oriented, and service composition becomes very exciting at that point. So service logic in SoaML is defined as a behavioral formalism where you have some formal notation of a behavior. However, it does not illustrate how to do that. In fact, it's very hard even for die-hard executable modeling gurus to define executable behavioral formalism. We don't agree on that. So what UML camp and executable UML camp is doing within OMG is standardizing that behavioral formalism, and the first attempt at that is the UAL, UML action language, which is going to be part of RSA fairly soon. So we have some product management people from RSA. They can tell us when that's going to happen. But so for now, what is going on is the behavioral formalism exists as a framework, but the syntax of the behavior itself, the action language that is fairly open at this point. But TelcoML is sensitive to that, so it does not tell you have to use the Rhapsody action language or behavioral formalism, for example, or the old Tel logic. It leaves it open for you to do whatever executable framework is reigning at the company, and eventually that behavioral formalism will be standardized, as I said, by OMG, and then hopefully we'll have a standardization in the service logic and service composition area. So what we do is then in TelcoML, to define this service composition, we have executable complex behavior such as voice-based transaction in terms of a state machine, and which is at the heart of any kind of a behavioral formalism. So state machines represent a bigger abstraction, the automata, more Mealy-style automaton. But in a service, especially in a complex telco service, that becomes essential to formalize as a state machine. Otherwise, it's going to be really difficult to maintain and extend that design. So again, from the modeling legacy that we all have, and I have personally, a majority of the world's wireless systems are designed using this behavioral formalism. In fact, at Tellogic, we had a slogan that 80% of the world's mobile and cell phone code is model generated and then executes based on executable model, especially on the GSM side of the wireless. So that spirit lives within TelcoML of the executable model. And then the other things, and this was added on by the France Telecom team, is that a lot of the notation that is used in that state machine formalism comes from the ITU, the Standards Organization, which maintains a language called SDL. And a lot of the SDL was absorbed into UML 2 and 2.1, so that formalism exists in TelcoML as well. And I'll give you an example of that in the next slide. Also, have the computation paradigms. That is part of that service logic that TelcoML preserves. And then we use the triggers and actions for things like voice and multimedia play capability using the same event-driven behavioral formalism. So I'll give you a representative diagram of how this service composition looks like. If you look at the UML as an executable modeling standard, you realize that the state machines or the behavioral formalism is defined in two different flavors. So you can have a data-oriented, or sorry, a state-oriented state machine, but also an event-oriented state machine, which is this example. So this is a event-oriented state machine. Currently, you can use this flavor of state machine in all our modeling tools, Rhapsody, RSA, old logic tools, which are more or less defunct now. But if you notice that the states itself are not very prominent in this notation, but it's the event and the triggers that are highlighted in this flavor of state machine. So in this example, once you initialize in a passive white box, you are taken out of that initialization state by a trigger. In this case, it's called subscribe to message, for example, and shown in yellow. So it's an incoming, it's an outgoing, event. And then outgoing event takes you out of the initialization state and puts you in the waiting state. So basically then the triggers and the events are highlighted because of that yellow box there. And then when you're in the wait loop, you wait for either a message event to come in or alarm event to come in to take you into the subsequent branches. And actually there's nothing that can stop both those events, message event and alarm event, to come in simultaneously, and you'll have parallel execution. So slightly illustrative, but you'll realize the power probably of the behavioral notation right now is that you could model parallelism, you can model multi-core execution, all using this behavioral formalism. Now, what's not illustrated very detailed here is the notation of the action language. For example, the very top yellow outgoing event says return equals IM.subscribe to message. That is an action language, basically. And also the variable definitions to the top box, the top red box. Those are all the static variables we're using within the state machine's scope, or not just the variables, but also the calls that we're going to make within the scope of the state machine. So that's also part of the action language. And right now it's using the old telelogic action syntax here from ITU. But this is what UML action language, UAL, is going to substitute. Currently, OMG is using a language called ALF as the action language. And once ALF does become ALF, by the way, once that becomes a standard, then we will put TelcoML notation in ALF as OMG subscribes to. So it's going to be following the same executable standard as UML does, which is makes sense, I think, to me at least. So moving on then, I think we illustrated the executable and service composition part really well. We went to their product architects, and they basically told us what they expect TelcoML to do. And the first thing they wanted us to do was to be compatible with their Joseph framework. And the Joseph framework uses a bunch of other technologies, and for example, the executable framework from Rational, but also Case-Wise and TigerStripe and so forth. It's based on the TigerStripe, actually. So what they were expecting us for two things from us is that their SoaML should be easily importable into their framework of Joseph, but also they can generate code from the enabler library of the TelcoML easily using Joseph. And the second part was that once they're able to do that, they can do the full source code and executable model development from Joseph without changing the syntax of our, or the structure of our TelcoML. So this far, since this slide was done, and now they were able to do all this. So now the whole TelcoML is part of the Joseph framework as it pertains to SMI that they have. So that's one of the good progresses, and it's giving us a lot more marketing. So next TM Forum big conference that's coming up, not Management World, but the subsequent one, I think we're going to make a big hoopla with them about our joint working between OMG and TM Forum, and hopefully make this into a fairly widely adopted standard. Again, the executable model part, both from a Joseph perspective and Rational's OSD ADC perspective, it's not a new thing for us. This is the Rhapsody diagram of an old executable model of a stopwatch, and you can express TelcoML, this in TelcoML, without too much change, and put things like a face plating on it so you can actually productize your model and see how your product's going to react while the model is executing behind the product itself. You can productize the model very quickly using things like faceplate that we're using right now. So a very cool thing, and this is obviously using a Rhapsody Android emulator that we have in Rhapsody as part of the mobile development kit that we have. So fairly powerful capability. So I just wanted to conclude, and then we'll open for more questions later.
Yeah, you got about 10 minutes. You got about 10 minutes left.
Yes, thank you. So I'm just finishing my last slide or so, and then we'll open up. I just wanted to finish by telling you where we're going with this. I just mentioned that SMI is the more exciting new progress that we're modeling in TelcoML after the OnAPI, but we are planning on, as asked earlier, stress a little bit more on the BPMN connections we have, especially from the SoaML perspective, but also for ETOM, which is the TM Forum's BPM framework. How do we relate to those two? So we're going to hopefully include all those in the TelcoML in the future. But we also want to focus a little bit more on CSP, the service provider itself, not just the devices, from an OSS BSS perspective, because SoaML does a great job of it, and we want to preserve that in TelcoML. And also service management, for example, creation, execution, measurement of service. We want to include that at least as a context in TelcoML. A little bit on CSP, and then I'll conclude. CSP, the service provider, basically have a bunch of definitions of their operational services that are SOA-based: performance management, event fault management, network management, monitoring. Same with assets and customer service trouble ticketing, and so forth. They're all done based on a SOA interface and is already defined by CSPs. So those are great candidates to also be done in TelcoML. Why do we want to do that? Is because we want to have the same TelcoML language that's running in the field, in the devices, to be running at the CSP. That way the data alignment and the service interfacing is common between the two. So that not only allows them to operate interchangeably and exchange data at runtime, but CSPs and the devices can also share components, model components, which is the main thing. So when you're doing SMS type of implementation at CSP, you could use the same SMS components you're using on your devices. So which makes it a very lucrative and shareable and a collaborative environment. So that's our goal here, and hopefully we will make that a very powerful standard because of that CSP and device sharing paradigm that we're talking about. So that's it. Any questions?
Yeah, I have a question. I see that you're looking for ETOM, but I don't see, and I don't see TAM. And the reason I'm mentioning TAM, first, France Telecom Orange, what they call FTOM is in fact TAM, the telco application map. And in fact, TAM can serve very easily as a component model structure, for the implementation.
I agree with you. The reason I included ETOM was because I wanted to highlight some of the the organizational modeling, business process modeling. TAM, we're waiting for the frameworks to be a little bit more well adopted and better interpreted. Then we will definitely look at the TAM. You're absolutely right, from a frameworks perspective, that is. I'm not sure where TAM fits into the new frameworks, but it may be just because I haven't mastered the frameworks yet, the standard yet.
Well, and France Telecom, in fact, when you look at what they've done, it's really a TAM model that they have. What they call FTOM is a TAM.
I see. I'll definitely bring this up to my friends telecom team. We talk every 2 weeks, so next week we're going to talk, and I'll bring this up. Thanks for telling me.
If no one has any remaining questions, then Irv, I want to say thank you for today's presentation. Clearly, standards are the way to drive adoption in the industry on a broad support basis, and a standard like TelcoML and all the product support that we provide for that clearly is our avenue for helping our customers derive value from implementing standards in an open fashion. So thank you for all your support today. Appreciate it, and I wish everyone success after today's call.